The table shows experimental value of the variable xy. Copy and complete the following table. So x is 0.5, 1.0, 1.5, 2.0, 2.5. And then we have the xy, 1 times 0.5, then is 0.5. And then 1 times 3, 3.0. And then we have the 1.5 times 3.67, then is 5.5. And then we have the 2 times 4, 8. And then we have the 2.4, 2.5 times 4.2, then it's 10.5. Okay, so the question asks us to draw a graph of xy against x. So xy against x, so the value of x, we have 0, 0.5, 1, 1.5, 2, 2.5 here. And then we have this one, we can have 11, and then 10, 9, so 10, 9, 8, and then the 10, 9, 8, and then 7, 6, 5, 4, 3, 2, 1, 0. Yeah, so we have a 0 here. Okay, and then this one, okay, x-axis and the y-axis. So we have the x-axis and the y-axis here. So this is y, and then this is x. So we have 0 0.5, 1, 1.5, 2, 2.5, and then 0. We have the what here? 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10, and then 11. Okay, so 0 0.5, 0 0.5. Okay, 0 0.5, 0 0.5, 1, 3. Okay, so something wrong with my answer already. Okay, because if I continue, for sure, okay, I cannot get the y-intercept, so cannot. Okay, so this one, um, we will have this as 12 here, 10, and then 8, 6, 4, 2, 0. Okay, so this is the x-axis, and this will be the y-axis. So the y-intercept will be negative for this case. Okay, so we must leave place for the y-intercept. So we have the 12, 10, 8, and then 6, 4, 2, 0, negative 2, 0 0.5, 1, 1.5, 2, 2.5. This is x, and this is xy. So 0 0.5, 0 0.5. So 0 0.5, 0 0.5. And then 1, 3, 1, 3. And then 1.5, 5.5, 1.5, 5.5. And then 2, 8, 2, 8, 2, 8. And then 2.5, 10.5, 2.5, 10.5 is here. And then we need to draw the line of best fit. So the line of best fit must pass through as much point as possible. Okay, so this is the line of best fit. Okay, Okay, so from here, we know that the y-intercept is -2. Okay, and then we can choose a point between the last and the second last point. So let's say we take this. This is the 2.25 and then 899.2. Okay, so we have the 2.25, 9.2. Okay, and we have the 0, -2. Okay, 0, -2. So we have the 0, -2, and this 2.25, 9.2. So they want us to express y in terms of x. So the gradient for this one, okay, the c is -2. So the gradient is 9.2 minus -2 over 2.25 minus 0. So we have the 11.2 divided by 2.25. So it's around 5. Okay, around 5. So we have the xy equal to 5x minus 2. Okay, capital X equal to M capital Y plus C. So this is C, this is M. So this is the capital Y, this is the capital X. Okay, so we have the Y is 5x minus 2 over X will be the equation. Okay, I make a mistake here. Okay, so this is the capital Y, okay, equal to M capital X plus C. Okay, so this is Y equal to mx plus C. And then find the value of x when xy equal to 2. So xy equal to 2, so xy equal to 2, we substitute into this equation. Then we have the 2 equal to 5x minus 2, 4 equal to 5x. Then x will be 4 over 5, 0.8. Okay, so uh, for the part D here, they want us to find the value of x and y. So we have the 0.8 times y equal to 2. So y is 2 over 0.8. So 2 divided 0.8. Then we have the 2.5. Okay. So when x equal to 0.8, y equal to 2.5. And then for this equation, I just leave here. But the answer given in the textbook is y minus 2 over x. Okay, so this two is actually equivalent. And then we want to check the gradient and the y-intercept that we get is correct or not. What we do is we press menu, go to number 6, statistic, and then go to number 2, y equal to a plus bx. Then the x we have 0 0.5, 1, 1.5, 2, 2.5. And then the y we have 0 0.5, 3, 5.5, 8, and 10.5. So after we key in, we press AC, and then we press option number 3, regression. So in the calculator, they will give us this. So the capital Y equal to negative x plus 5 capital X. So xy equal to 5x minus 2. Okay. And then we can also do something like this. The last point is 2.5. So 2.5, option down, number 4, regression, number 5, y hit, then it's 10.5. So when x equal to 2.5, then the graph is 10.5. We connect the 10.5. So 2.5, 10.5, and the 0, -2. Then this is the line of best fit. Okay, done.